Mastering legacy system scalability. Someone must be held accountable for the system's reliability and scalability, or the business will suffer. Who within the organization is responsible for defining and ensuring that the current system meets its reliability and uptime requirements? And how do these requirements impact the ability to scale the system to meet growing business demands? Establishing clear ownership and accountability is crucial for ensuring the reliability and uptime of a legacy system. This responsibility typically falls on the shoulders of a senior technical leader, such as the Director of Engineering or the Vice President of Operations, who oversees the entire technology stack and is ultimately accountable for the system's performance. This individual, in conjunction with other stakeholders, must define the system's reliability and uptime requirements, which are typically based on business objectives, industry standards, and regulatory compliance. These requirements are often quantified in terms of key performance indicators, KPIs, such as uptime percentage, the percentage of time the system is available and accessible to users; mean time between failures, MTBFE, the average time between system failures or outages; mean time to recover, MTTR, the average time it takes to resolve an outage or failure; response time, the average time it takes for the system to respond to user requests. These KPIs serve as the foundation for operational excellence, ensuring that the system meets the required levels of reliability and uptime. The defined requirements also have a significant impact on the ability to scale the system to meet growing business demands. To ensure scalability, it is essential to 1. Monitor and analyze system performance. Continuously monitor the system's performance, identifying bottlenecks and areas for improvement. This involves collecting metrics on resource utilization, response times, and error rates, which are then analyzed to identify trends and patterns. 2. Implement proactive maintenance. Regularly perform maintenance tasks, such as software updates, backups, and hardware replacements, to prevent failures and reduce downtime. 3. Implement redundancy and fault tolerance. Design the system to have redundant components and fault-tolerant architecture, ensuring that the system remains available even in the event of hardware or software failures. 4. Develop a capacity planning strategy. Analyze the system's current capacity and forecast future demand, ensuring that the system is scalable to meet growing business needs. 5. Prioritize feature development. Prioritize feature development based on business objectives, focusing on features that will have the most significant impact on revenue growth or customer satisfaction. 6. Establish a continuous integration and continuous deployment (CI/CD) pipeline, automate testing, deployment, and rollback processes to minimize the risk of deployment-related outages and ensure rapid recovery in the event of an issue. 7. Foster a culture of collaboration and communication. Encourage open communication and collaboration among stakeholders, including development, operations, and business teams, to ensure that everyone is aligned on system reliability and uptime requirements. 8. Continuously review and refine processes. Regularly review and refine operational processes, identifying areas for improvement and implementing changes to optimize efficiency and reduce the risk of errors. By implementing these measures, organizations can ensure that their legacy systems meet the required levels of reliability and uptime, positioning themselves for scalable growth and long-term success. As I delved into the world of legacy system scalability, I couldn't help but think of the precarious tightrope that organizations walk between maintaining operational excellence and meeting growing business demands. It's a constant balancing act, where one misstep can have far-reaching consequences. I recall working with a global financial institution that was struggling to scale its core banking system, built over 3 decades ago. The system was a behemoth, with millions of lines of code and a tangled web of integrations with other systems. Despite its age, the system remained the backbone of the institution's operations, handling millions of transactions daily. The challenge was twofold. Firstly, the system was experiencing frequent outages, resulting in significant revenue losses and damage to the institution's reputation. Secondly, the growing business demands required the system to handle increasing volumes of transactions, which it was ill-equipped to handle. As I dug deeper, I realized that the root cause of the issue lay not in the technology itself, but in the organization's approach to operational excellence. The institution had become complacent, relying on quick fixes and patches to keep the system running, rather than investing in a comprehensive overhaul. I worked closely with the institution's top executives to identify the key stakeholders responsible for defining and ensuring the system's reliability and uptime requirements. We pinpointed the Chief Information Officer, CIO, the Head of Technology Infrastructure, and the Head of Operations as the primary custodians of the system's operational excellence. Together, we established clear key performance indicators, KPIs, to measure the system's reliability and uptime. We set a target of 99% uptime, with a maximum of 30 minutes of downtime per quarter. We also defined a set of service level agreements, SLAs, that ensured prompt incident resolution and problem management. The next step was to assess the system's current architecture and identify areas for improvement. We conducted a thorough analysis of the system's components, identifying bottlenecks and single points of failure. We developed a roadmap for incremental improvements, focusing on simplifying the architecture, reducing technical debt, and implementing automation and orchestration. One of the most critical decisions we made was to adopt a fail-safe approach, where we prioritized system resilience over feature development. We implemented a robust monitoring system, which provided real-time visibility into system performance and alerted the team to potential issues before they became incidents. Throughout the process, I was struck by the institution's willingness to confront its own biases and assumptions. It was a humbling experience for everyone involved, as we recognized that our own complacency had contributed to the system's decline. As we began to implement the changes, I felt a sense of trepidation. Would we be able to overcome the technical challenges and deliver the required improvements? The answer was far from certain. However, with each incremental success, the institution's confidence grew. The system's uptime improved dramatically, and the frequency of outages decreased. The business was able to scale, handling increased transaction volumes with ease. The most significant outcome, however, was the cultural shift within the institution. The teams began to work together seamlessly, sharing knowledge and expertise to drive operational excellence. The CIO, once seen as a guardian of the status quo, became a champion of innovation and change. As I look back on that journey, I am reminded of the importance of critical thinking, moral courage, and creative problem solving in driving operational excellence. It's not about finding quick fixes or band-aid solutions. It's about confronting the brutal facts, making tough decisions, and investing in people and processes. Legacy system scalability is not just a technical challenge, it's a human one. It requires leaders to confront their own biases, to listen to their teams, and to make difficult choices. It requires a deep understanding of the organization's values and a commitment to doing what is right, even when it's hard. In the end, it's about creating a culture of operational excellence, where people are empowered to make a difference, and where the organization is able to adapt and thrive in a rapidly changing world.